All right, let's talk about factoring the difference of squares. So quick reminder, a difference of squares is a problem where like a squared minus b squared is equal to a plus b times a minus b. You've seen it the other way around, right? Where this is a difference of squares because it's like you're squaring a plus b except one's addition and one's subtraction, right? So it's a different signs. And what ends up happening here, remember, is that our middle terms will cancel out, right? Because this would give us AB, this would give us negative AB, and AB and negative AB cancel out, right? So you end up just having two terms in your answer. So factoring something with two terms, if you notice, like if I factor x squared minus 4y, if you notice, this is a perfect square minus a perfect square, right? So it's just really easy to factor this by breaking the square root of x squared is x, so I can break x squared into x times x, and the square root of 4y squared is 2y, so I can break that into 2y times 2y. Because it's negative, we're going to have opposite signs here, right? So just recall, again, when you do FOIL, we would multiply x times x is x squared, right? We would then multiply x times 2y to give me 2xy. Then I would be negative 2y times x is negative 2xy. And then negative 2 times 2y is negative 4y squared. And again, my middle terms, they're opposite of each other, so they completely cancel out, leading me back to x squared minus 4y, right? Same with this next one. This is a perfect square minus a perfect square. So all we have to do is use the square roots as my terms in my factors, knowing that it's a plus and a minus inside there, right? And just again, refresher, if I'm checking my middle term, this would give me negative 20r. This would give me positive 20r, and that's why we don't have an r term. It completely canceled out. Because remember, this really is just the same as 6r squared plus 0r minus 25. The 0r we would never write down because that's 0. So let's go ahead and try a few. So a difference of squares is always going to be a perfect square minus a perfect square. It's really easy to factor these if you can recognize it. So x squared minus 25, all you have to do is break that into x plus 5 times x minus 5. Or you could write it as x minus 5 times x plus 5. Number 2, y squared minus 9, well, that's just going to be y plus 3 times y minus 3. If you don't believe me, go through and do FOIL. The next one, I've got x to the 4th minus 81. Well, x to the 4th is a perfect square. We can break that into x to the 2nd times x to the 2nd. And negative 81 is a perfect square, so I'm going to make that plus 9 and minus 9, right? Now, I want to put a star by this one because I'm not done, right? Right here, I have an x squared minus 9. Isn't that a perfect square minus a perfect square? That one can go further. So that is going to break into x plus 3 times x minus 3. And then this guy just comes right back down. It can go in front of it or it can go behind it. This particular problem has 3 factors. Now, you might be asking, well, couldn't I break up x squared plus 9? And the answer to that is no, right? Because if you think about breaking up x squared plus 9, just think about that for a second. In order to get a positive 9, I would have to have my signs the same. So I want you to think about that. If I'm breaking up x squared into x and 9 into positive 3 and positive 3, reminder, this is the same as x plus 3 squared. We will definitely have a middle term here. Think through FOIL again. Multiply my first terms, I get x squared. Multiply my outers, I get 3x. Multiply my inners, I get 3x. Multiply my last terms, I get 9. What happens here is I get a 6x in the middle. So my middle term won't cancel out if my signs are the same. The same is true if I make them both minus signs, right? If I change these to both minus signs, that just means that I have negative 6x in the middle, right? Well, then you might be like, well, couldn't the signs be different? Well, yeah, they could be different, but remember, if they're different, that wouldn't be a plus sign. That would be a minus sign. So you can only factor something that is a binomial that's a perfect square minus a perfect square. If it's a perfect square plus a perfect square, it doesn't work out because of our rules about special products. So now I'll go ahead and stop the video and go ahead and try the next set of problems. Go up to number 12 and see how you do, and then tune back in, just double check to see if you're correct. And here are your answers. Notice that I kind of switched the order of my plus and my minus sign, right? So it doesn't matter if the plus sign comes first or second. Here I have 7 plus x and 7 minus x, and here I made it a minus b, a plus b. Remember, the commutative property of multiplication says it's okay to do that. So go ahead and take a look at your answers, and if you got any wrong, see if you can figure out what you did wrong. And if I am in the classroom with you, you should go ahead and ask me or make a note about it if you're confused. So moving right along, remember how I taught you on the first day of factoring to pull out a GCF. Whenever you're asked to factor, that really is the very first step. You should look at the problems and ask yourself, do I have a greatest common factor? And if I do, I have to pull it out. And then from there, if you're still left with a binomial or a trinomial, you later then ask yourself, can I factor further? All right, so all of the ones here are just binomials. Remember, you can only factor a binomial further if it's a perfect square minus a perfect square. So looking at number 13, right away, it's not a perfect square minus a perfect square. However, we do have a GCF. So my GCF of 8x squared minus 12 is 4, right? So that's a factor. 4 is a factor, so I have to write the 4 down. And then remember, when I pull out the 4, I'm dividing 8x squared by 4 to leave me with 2x. And then negative 12 by 4 to leave me with negative 3. I'm sorry, it's 2x squared. So now I'm done with this problem. I can't factor 2x squared minus 3. And you might be thinking, I really don't understand why. So let's just think about it, right? If I were to try to factor that, your inners and outers would not cancel out no matter what. There's only one way to break up 2x squared, it's 2x and x. And there's only one way to break up 3, it's 3 and 1. So let's just say I put the 3 and the 1 here, right? My signs would have to be different. If you look, I would get 3x, and then here I would get negative 2x, right? That would give you 1x. So my middle terms won't cancel out. Same would happen if I change it. If I put the 1 here and the 3 here, I'm still not getting opposite signs, right? In order for your middle term to cancel out, it has to be two factors are exactly the same with the same numbers in there, 1's plus, 1's minus, right? It has to be a difference of squares. If it's not a difference of squares, it cannot be factored further. So now number 14, there's not a GCF. However, you might be thinking, well, it's a perfect square plus a perfect square. But that doesn't work, right? It has to be a perfect square minus a perfect square. Because of the addition sign, this one we're going to say is prime. We cannot factor that further. Number 15, that one right there, is there a GCF? Is there something that goes into 16x squared and negative 25? No, there's not. So I'm going to see if can I factor this further. I can, because 16x squared is a perfect square and so is 25. Oh, and it's subtraction. This is a difference of squares. So I'm going to break this into 4x plus 5 times 4x minus 5. And then I'm done. All right, let's take a look at number 16. Number 16, do I have a GCF? I do. It's 4. So I'm going to pull out a 4. And when I pull out the 4, I'm going to be left with 3x squared minus 2. Again, 3x squared minus 2 is not a difference of squares because 3 and 2 are not perfect squares. So I'm done with that problem. My factors are 4 and 3x squared minus 2. Looking at number 17, pull out your GCF. My GCF is 2. When I pull out a 2, I'm left with 9x squared minus 4. Oh, that's a perfect square minus a perfect square. 9x squared is a perfect square, and so is 4, and it's being subtracted. So I have to take this further. Don't forget about your GCF. That's still a factor. So I bring down the 2, and I'm going to be left with 3x plus 2 times 3x minus 2. Don't believe me? Go ahead and do FOIL with that, and then that will bring you back to this. Then distribute the 2 in there, and that will bring you back to your original answer. So that one is now fully factored. Let's try one more together. And number 18, what is my GCF? I'm thinking of 50 and 8, numbers that go into 50 and 8. I'm going to go with 2. So I'm going to pull out the 2. 50 divided by 2 is 25, so I'm left with 25x squared here. 8 divided by 2 is 4, so 25x squared plus 4. Now your brain might be going, that can go further because those are perfect squares, but I can't because of the addition sign. It has to be a difference of squares. Minus sign there. All right, go ahead now, stop the video, try the rest of the problems on your own, and then tune back in. Make sure that you've done them correctly. And don't forget to pull out a GCF. That is always your first step. Pull out a GCF if there is one. Factor further if you can. Okay, so here are your answers. I want to point out number 19 to just start with, because many people look at the 16x squared minus 4 and are immediately like, oh, that's a perfect square minus a perfect square. However, it did have a GCF. So I had to pull out a 4 first, and I'm still left with a perfect square minus a perfect square. That 4 comes down, and I'm left with 2x plus 1 and 2x minus 1. Now, some of you might be like, but what I factored, it worked. It did work. But you have to, your factors cannot contain perfect squares. So let's just say you started this problem by going through and doing 4x plus 2 times 4x minus 2. The reason this is wrong is because you can't have a GCF, right? Here you have a GCF that can come out of 4 and 2, right? I can pull out a 2. So if this is your answer, let's just finish it, right? Pull out the 2. And when you pull out the 2, here, let me change my color here. Oh, I don't like that color. All right, so pull out the 2. And then when you pull the 2 from this set of parentheses, you're left with 2x plus 1. And then over here, you still have a 2 in here. If I pull out that 2, it's being multiplied, you get 2x minus 1, right? So then notice, because this is all multiplication, this is not an addition sign, this is a multiplication sign, you can multiply 2 times 2, which brings you back to that answer. You get a 4 on the outside, and then these factors, 2x plus 1 and 2x minus 1, can go together. So your factors cannot contain any GCFs, or it's not fully factored. Okay, so the next one's, notice there's only a few that could go further, right? Number 22 was a perfect square minus a perfect square, so I had to take that one further. Number 26 I had to take further, and number 27 I had to take further. Any of the other ones I couldn't go further because they weren't both perfect squares left inside the parentheses. All right, that's all for this one. Let me know if you are stuck anywhere.